Any questions so far on problem 15 there, just identifying first point slope form and then converting to slope intercept form, or point gradient form, identifying to gradient intercept form? Okay, good. Example 16, pretty straightforward. Says a straight country road with equation y equals negative 0.075x plus 11.5 intersects two state highways with equations x equals 0 and y equals 0. So what I would do here is I would start by saying, let's go ahead and create our x-axis here and our y-axis, and we'll say this one is x equals 0, that's our y-axis, and then this one over here is the x-axis, and this is y equals 0. And it says that this road is at 11.5, so let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so we could just say 12 up here, and then the y-intercept would be at 11.5 right there. And then we'll say 11, 10, we don't need to count, we don't need to put every line, we'll do 10, 8, 6, 4, 2, and 0. And then just for simplicity's sake, we'll probably just count the x's by the same. We'll just go 2, 4, 6, 8, 10, 12. Okay. So now it's saying the slope is negative 0.75 plus 11.5. I chose the scale of 1 just because I know 11.5 is going to fall up here. That is our y-intercept. And now to graph this thing by hand, that slope's going to be a little bit tricky. I'm probably going to want to change that into a fraction if possible, right? Which your calculator does have a fraction button. You can always put negative 0.075 in there and then hit the fraction button. This is going to be, what is this fraction? 0.075. That's going to be, I don't have my calculator on me because I would want to do the same thing because I don't know that off the top of my head myself. Does somebody have their graphing calculator where they can convert that into a fraction? I think it should be 3/40. So negative 3 over 40, which isn't, okay. Which that's kind of annoying because if I were doing slope, I would go down 3, 1, 2, 3, and then over 40. That seems very extreme. Yeah. Or I could go like, another way I could write this is negative 0.3 over 4. So I could go down like 3/10 and then over 4. 1, 2, 3, 4. And then down 3/10. And then over 4. 1, 2, 3, 4. So it doesn't look like my equation's going to be awesome here. I think if I'm doing this the right way. Down 0.3 over 4. 1, 2, 3, 4. It seems like it would get off the paper very fast. So maybe I didn't pick the best scale for my road, I think. I'm thinking that might be the bad graph to draw. Let's see. Trying to think here. Aha! I see what I did wrong. So the I did a 0.75 there. That should be it should be 0.75. Aha! That'll make it much easier. Trying to figure out why I'm doing 3/40 here. So it'll be negative 0.75, so that way we get a better graph. Let's fix that. I like that more. So that's just a typo. I'll fix that typo later, but essentially this is negative 3/4, which I like because now if we're at 11.5, we're going to go down 3, 10.5, 9.5, 8.5, and over 4. 1, 2, 3, 4. That'll be easier to graph. and then down 3, 1, 2, 3 over 4, 1, 2, 3, 4, down 3, 1, 2, 3 over 4, 1, 2, 3, 4, and there's our line. That's much better. And it's going to intersect over here somewhere between 15 and 16 would be my guess. Now it says find the exact location of the two beverage shops. So we know, like, we're opening the two beverage shops. One of them is going to be the intersection of the country road and x equals 0. The other is going to be the intersection of the country road and y equals 0. So for the first one, you would say when x equals 0. So y equals 0.75 times 0 plus 11.5. So it's going to be at y equals 11.5, or at the point 0 comma 11.5. That's the first one. The second one, you'd set y equal to 0. And you subtract 11.5 from both sides. All right. And we'll get 15 and a third, or 15.3. All right, that would be the x value. So this comes out to 15.3 comma 0. That would be how we find the second one. And then part C says find the distance between these beverage shops. So distance, we would use the distance formula, which would be given to you on an IB exam. Excuse me. Another way to remember distance formula is it's like Pythagorean theorem, right? We have a triangle here, and you technically know this side and you know that side. So you could do like an a squared plus b squared if you wanted to here. All right. But the distance formula is going to be the square root, all right, of the x values squared minus the y values squared. So in this case, it's going to be, I'm sorry, plus the y value squared. So in this case, it's going to be the square root of 15.3 squared plus the square root of 11.5 squared. And it would normally be like the difference in the x values minus the difference in the y values, but because we have, it's 15.3 minus 0, because that's the first y value. And then the other one's 11.5, 0 minus 11.5. And those would all just become 15.3 squared and then negative 11.5 squared, just so you guys see where that's going exactly. And then we can go ahead and plug that into our calculators. And we should get a total distance of 19.16 repeating. All right. So we can say, let's see, does it give us any units here? No, it doesn't. So we'll just say 19.16 is the distance between the two. All right. That's the idea for example 16 here. Okay, now I put 3 practice problems on here, and for each of these problems I want you to rewrite them in slope-intercept form. So example A is in standard form, and then example B is point slope form, and example C has an x on one side when it should have a y on that side. So just go ahead and solve those 3, see if you can rewrite them in slope-intercept form, or slope gradient, or gradient-intercept form, whichever way you want to call it. All right, so practice those 3 now. All right, go ahead and check your answers on those 3 problems. Make sure you're feeling okay with just converting to slope-intercept form. Oh, I love this math. This is so much better than calculus, right? Just to end the year on something easy, right? After we did all that hard stuff, the statistics, the probability, and then come back to this stuff. Okay, last example today says that two straight roads have equations y equals 3x plus 15 and y equals negative 2x plus 5. A traffic light has to be installed at their intersection point. Find the coordinates of the intersection point of the two roads. So we have a couple methods we can do for this problem. You can do graphing. All right, so graph the two lines, identify the intersection, okay? Identify the intersection of the 2 points. Via the graph. The other way you could do it is algebraic. Set the two equations equal to each other. All right, set the two equations equal to each other. That's what graphing's all about. So we say 3x plus 15 equals negative 2x plus 5. And we'll solve for x. I'm going to add 2x to both sides. I get 5x plus 15 equals 5. 5x equals negative 10. X equals negative 2. Once I have that, plug into one of the equations to solve for y. Technically, I can plug into both equations and prove that I did it right. So I could do 3 times negative 2 plus 15 in this one. And on the other one, I could do negative 2 times negative 2 plus 5. And I should get the same number either way to prove that I did this correctly. And on this one, I get y equals 9. On this one, I get y equals 9, which is perfect. That's the good way to double check that I did it correctly. So my ordered pair is negative 2, comma 9. You can do it algebraically, or you could do it graphing. So graph and identify the points via the graph. If you were to do this like via graphing on your homework, I would just ask you to take like a screenshot of your graph from Desmos and then go ahead and put that into put that onto your homework assignment or whatever you need to do, okay? But you can do either method. I like to see the algebraic method myself, just okay. But that's the idea for today's assignment, is just looking mostly at slope-intercept form. All right.